finding the equation of the axis of symmetry using the equation, okay? Page 12. Okay, I'm going to highlight that to make sure that I know that I talked about it with you guys. Since a parabola is symmetric, meaning it can be cut in half, and you have the exact two halves, right? They would match perfectly. Points on either leg are, here's a word of the day, equidistant, right? From the AOS. They are the same distance apart, okay? When would you be using this? When you have no vertex, obviously. That's when you would use this concept right here. If you are given 2 points that have, highlight this part, the same y value, 2 points with the same y value, right? So 2 points that have the same y value, we can find the value of the axis of symmetry using, so to figure out the AOS, okay, no vertex provided. We find it out this way. We go x1 plus x2, and we divide that in half. Basically how we figure it out. X represents the axis of symmetry. X1 is value of first point. X2 is the, you know what? Should I be a bit more specific? Sorry, I'm going to make this arrow a bit shorter. It's the x value of the first point, not just the value, right? X2 is the x value of the second point. So this one is definitely study sheet worthy. I'd say anything that's boxed in and has highlighter around it, I would very seriously consider adding this to my study sheet. Normally, if we knew the vertex, we would not bother with this. We would just go x, like, hey, it's the x value of the vertex. But if you don't have the vertex, you use this guy. Okay, so here's a visual of this. Okay, so determine the axis, the equation of the axis of symmetry of the parabola below. Note, vertex is visible, but assume we don't know it. Assume it is unknown. Otherwise, you would be like, why are we bothering? Why are we doing all this stuff? Like, we know. Like, can you tell what the vertex is right now? It's what, 2, 3, right? The coordinates of the vertex is 2, 3. So we could clearly tell that the axis of symmetry is 2, right? So this is what we're interested in. We're trying to find the equation of this imaginary line that will cut through that vertex, okay? So we're trying to figure out what is the equation of this line. What is it? Okay. So you notice that these two, let's say you were given these 2 points here. They're both at a height of 11. We're going to call this x1, and we're going to call this x value x2. They're at the same height. That is important, otherwise this doesn't work. They need to be right across from each other at the same height. So the axis of symmetry in this case would simply be -2, that's x1 for us. It doesn't matter which one you call x1, which one you call x2, it doesn't matter. Plus 6, put that in brackets, divide that by 2. Negative 2 plus 6 is 4. Divide that by 2 is 2. Therefore, the axis of symmetry is 2. You can also use these 2 points here, or you call this x1 and this x2, right? You have x1 here, you have x2 there. Guess what? You're going to get the same answer. It's going to be 0 plus 4 divided by 2. That's 4 divided by 2. That's just 2. So both of them give you the same answer. As long as you have 2 points that are right across from each other, you're fine. This is just a concept. We're not going to necessarily do this very often, but we're going to base our something that we do in the future off of this. So I'm going to add something to this, okay? This point right here, what are the coordinates of this point right there? What would it be? If this is your origin, you'd go negative 3, and then we go, this is 5, 10, 15. So this is negative 3, 15, correct? If I asked you, what is the coordinate of that point? But imagine you don't have the graph available. We know this is also at a height of 15. But let's do some indirect reasoning here. We know that this is x is equal to 2. This is going right through x is equal to 2. How many units does it take us to go from the leg here on the left to the center? 1, 2, 3, 4, 5, correct? It will therefore, it stands to reason that will take 1, 2, 3, 4, 5 steps to get from the center to the other leg. So what is the coordinate of this x value without looking at the grid? 2 plus 5 is 7. Okay? Not 6, 7. Don't get excited. There's no such thing. Okay? So that kind of reasoning, I want you to think that's the importance of the axis of symmetry. We can kind of use it to figure out other things that are missing. Okay? So I'm going to say this is going to be your homework here. Figure out the axis of symmetry using these 2 points. It's not a whole lot. It's going to take you 2 minutes max. Okay? So I'm not going to do that with you here. That's on you. I need you to go to 13 with me. It's a little bit of a... I'm jumping a little bit. These are like the little miscellaneous things that I don't know where to put them, other than just like every once in a while just insert them. Okay? So finding a missing x value using the axis of symmetry or the vertex. It says determine the missing x value. So you get a point here and another point there. And we know that they're both at 5, okay? At a height of 5. Maybe let's make an arrow to it like this. Same y value. Same y value. That's important to notice. And the vertex, which is at 6, negative 10. What is this also known as? This is the axis of symmetry. Like that value gives you the axis of symmetry, which is what we call x. X is equal to 6. So I want you to use the reasoning here. Remember, axis of symmetry is x1 plus x2 in brackets divided by 2. That's the reasoning I want you to use here. We have x, that one is right there. We do have the axis of symmetry. We have x1. x1 is equal to 3. And x2, which is the unknown, right? We don't know what that is. So you can use this equation to figure out what that would be. So here we go. Insert. 6 is equal to 3 plus x2 divided by 2. And now we do algebra, okay? So we multiply this side by 2. We multiply this side by 2. We cancel out the 2 there conveniently. 2 times 6 is 12, leaving you with 3 plus x2. Subtract 3. x2 is equal to 9. So the missing point has coordinates 9. We used to not know. There was a question mark there. It's 9, 5. Okay? So you just figured it out. It's 9, 5. Can we do a little grid here just to envision this? If this is 5 and this is 10, this is negative 5, this is negative 10. And we're at 5, right? 5 going up here. And negative 5 here. Let's plot these points. 3, 5 is where? 3, 5 is right there. The vertex is 6, negative 10. 6, yikes. That's why we have erasers, remember? Remember that? I'm going to go negative 5 here, and this is going to be negative 10 for me. So 6, negative 10 is right there. And the point I just found is at 9, 5. 9, 5. Okay, so this is what I found. I found the coordinates. So now you can kind of picture, okay, the parabola going that way. Is this necessary? Absolutely not. Okay, this is actually overkill for a question like this. But that's what I'm finding there. I'm using the axis of symmetry to help me out, because this is your axis of symmetry going through 6. X is equal to 6, right? So from 6 to 3, this is 3 units here. So it would be another 3 to get to this side, which makes sense that it is 9. Okay. One more thing here, also miscellaneous stuff. Describe the direction of opening, the width, and the y-intercept of this parabola. Okay? This is in general form, by the way. That's important to understand. In the direction of opening, A is negative, so opens down. The width, what do you think? Wide or narrow? This is going to be a wider one, because the actual value, forget about the sign, the actual value is between 0 and 1, okay? Because A is between 0 and 1. That's why it's called a wide curve, okay? And the y-intercept, you could use your calculator, to be honest. I wouldn't know. You always get to use your calculator, but it is actually 0, right? It's 0, 0. Because C, if you want to add 0 here, that is the value of C. It's just invisible, but it's still there. Okay. So 0, 0. Because I used 0C as my help right, to figure that out. Okay. Next, determine f of 3 and f of -4 algebraically. What is this? We're going back to this function here. We're going to split this up. F of 3, everything that's has an x to it, we're going to insert 3 into it. That's what that is saying. So negative 0.02. 3 squared plus 12.5 times 3. I would say in this course, because it's applied, if you now type this into your calculator, you get the mark. I just want you to show me once that you're inserting 3. So if you grab your calculator and you go negative 0.02, just type it in exactly the way you see it. So you get 37.32. What did you just find, guys? When you do this, when you insert an x value, you're getting a y value in return. So you found a point on the graph. And what is that point? X is equal to 3, y is equal to 37.32. That's what you found when you do that. Okay? F of -4. Slow down, Mr. Dirksen. Take a deep breath. Make sure you write this down. I know that's what you were thinking, and I'm always looking at the clock. That's my problem. I apologize. That's why I'm recording, okay? That's my way out. If you need to see something again, you see it. You insert -4 into that original there. -4 squared plus 12.5 times -4. I need to make sure you understand this. What happens when you square a negative number? Always turns positive. So I need you to understand that. So if you want to type this in and just get an answer, that's fine. That is, I get -50.32. So you found a point, right? Point -4, -50.32. That's what you found. Guys, if you use your calculator, your cursor would blink at this location. It would just blink there. You just found a point. When x is equal to -4, it is at -50.32 on your y-axis. Okay? So that's that. I'm almost done, I promise. When I give you something like this, and I want you to state A, B, and C, this is what I have a lot of students. Don't write this part down, what is right here. Oh, A is what? Where is A located out of these three numbers? It is right there. 74.3, and some students do this. Please don't do the x squared part. I just want the coefficient in front of it. So it's just 74.3. B is whatever's in front of x. That'd be -3.75. And C is -345. That's all. I just need you to know that, because that something is coming down the pipe. We need to make sure you understand what is A, what is B, and what is C. Okay? That's it for now. There's, let me see. Let's see. Domain and range I need to talk about, but I'm not going to do that today. So your homework